Welcome back, everybody, to another deep dive with us. Today, we're diving into a topic that's becoming more and more crucial, and that's desalination for agriculture.
Right.
We've got a whole bunch of articles and research papers here, and they're all kind of circling around this question of, can we actually turn salty water into a lifeline for thirsty crops?
It's a big question.
It really is.
Yeah.
You know, imagine you're a farmer in the middle of just a scorching drought.
Right.
And even your traditional water sources are drying up.
Yeah.
What are your options?
Yeah, that's the situation facing a lot of farmers.
Exactly.
Especially out west, right, in the western U.S. I mean, water scarcity is becoming the new normal.
Right.
We've got some stories here about farmers just like struggling with this.
Yeah.
You know, they're having to implement all these different strategies.
Yeah, what kind of strategies have we talked about?
Like drip irrigation, soil sensors, even making tough choices like following fields or selling off livestock.
So they're really having to make some difficult decisions just to adapt?
Absolutely.
It seems like they're already doing a lot to conserve water.
Yeah, I mean, they're really on the front lines of this, you know?
Yeah.
They're dealing with the consequences of this.
So where does desalination fit into all of this?
Well, it's emerging as a potential tool.
Okay.
It's not a new idea, but it's one that's getting a lot more attention.
So I got to admit, I always thought desalination was mainly about, like, creating drinking water for the ocean.
Yeah.
You know, like seawater desalination.
Yeah, that is the most common application,
right,
especially in coastal areas.
Yeah.
But what we're seeing now is a growing interest in what's called inland desalination.
Inland desalination.
Which is using brackish groundwater.
Okay.
So groundwater that's further inland.
Okay.
That's salty.
Gotcha.
But not as salty as seawater.
So less salty than the ocean.
Right. And so it's not a new idea, but the technology and the economics are changing in ways that are making it more feasible for agriculture.
Okay, so let's talk about how desalinating actually works.
All right, so the most common method is reverse osmosis.
Okay, I've heard of that.
Yeah.
What is that?
Basically, you imagine a superfine membrane.
Okay.
Kind of like a high-tech filter.
Okay.
And when you push salty water through this membrane, it lets the freshwater molecules pass through, but it blocks the larger salt molecules.
Okay.
It's kind of like separating sand from water with a sieve, you know?
Okay.
Yeah.
Okay.
So you're basically filtering out...
So the membrane is the key.
Exactly.
Okay.
The membrane is what makes the magic happen.
So what makes this new research so groundbreaking?
Well, it's more than just cost reduction, although that's a big factor.
Yeah.
Researchers are exploring all sorts of innovations.
Right.
Take electrodialysis, for example.
Electrodialysis?
Yeah, it's a method that uses an electrical current to separate the salts from the water.
Interesting.
And it can be more energy efficient than traditional reverse osmosis, especially for brackish water.
Okay. Yeah, because you're saying it's not as salty, so it doesn't need as much.
Exactly.
Okay.
Exactly.
So electrodialysis, how does that even work?
So imagine a tank of water that's divided into compartments by these special membranes.
Okay.
And these membranes are designed to allow either positive or negative ions to pass through.
Oh, that's interesting.
But not both, right?
Wow.
So by applying an electrical current across this tank, we can force the salt ions, which are electrically charged, to move through these selective membranes, and that leaves behind the fresh water.
So it's like using electricity to kind of herd...
Yeah, exactly.
Those pesky salt ions into a separate area.
Exactly.
Okay, that's fascinating.
Yeah, it's pretty cool.
So the membranes, again, are key here.
Absolutely. The membranes are the heart of the system.
Okay.
And there's a lot of research going into developing new types of membranes that are more durable, more selective, and require less energy to operate.
So it's all about efficiency.
Yeah, the better the membrane, the more efficient and affordable the process becomes.
Okay, makes sense.
Yeah.
So we've got this cool science happening, but what about, like, real-world application?
Well, there's some exciting pilot projects underway.
Okay, tell me about those.
You remember Ralph Loya, the farmer we mentioned earlier?
Oh, yeah, the one facing the drought.
Exactly.
Yeah.
He's actually participating in a project at the Brackish Groundwater National Desalination Research Facility.
Wow, that's a mouthful.
It is a mouthful.
Where is that?
It's in New Mexico.
Okay.
And they're experimenting with electrodialysis for different crops.
Okay.
Different water sources, seeing how it performs.
So they're actually testing this out on crops.
Real-world agriculture settings,
Are the crops doing okay?
That's a key question, right?
Yeah, they're happy drinking this water.
And the early results are promising.
Okay.
They're finding that crops irrigated with desalinated water are showing good growth and yields.
That's great.
It depends on the crop,
Sure.
the salinity of the water,
Right.
other factors, but overall it's looking positive.
That's encouraging.
Yeah.
It sounds like this could be a real game changer.
Yeah, I mean, it has the potential to really make a difference for farmers
For sure.
who are struggling with water scarcity.
But I'm guessing it's not all smooth sailing.
It's not a walk in the park, no.
What are the hurdles that they're facing?
Well, one of the main challenges is cost.
Okay, yeah, that makes sense.
Desalination, regardless of the method, is still more expensive than using readily available fresh water.
Right.
But the gap is narrowing as technology improves.
Okay.
And so, for example, there's research at the El Paso plant that has shown that using electrodialysis to extract fresh water from the brine.
From the brine?
Yeah, so the salty byproduct of desalination.
Oh, interesting.
Could potentially lower costs significantly.
So they're getting even more fresh water.
Yeah, exactly.
Out of what was considered waste.
It's like double zipping.
That's pretty awesome.
Yeah, so there's a lot of potential there.
So besides cost,
yeah,
what are some of the other challenges?
Another big one is brine disposal.
Okay, yeah.
So when you remove salt from the water,
right,
you end up with this highly concentrated brine solution.
Yeah.
And this brine can't just be dumped back into the environment.
Oh, for sure.
Because of its high salt content.
Right, it would disrupt everything.
Right, you'd be basically polluting.
Yeah.
Yeah.
So what do they do with it?
Right now, the most common method is deep well injection.
Okay.
So basically pumping it deep underground.
Okay.
But this can be expensive and also raise some concerns about potential groundwater contamination.
So it's not a perfect solution.
It's not ideal.
Okay.
And so researchers are exploring other possibilities.
Like what?
Like extracting valuable minerals from the brine.
Oh, interesting.
Or even finding ways to further reduce its volume.
So trying to minimize that waste.
Exactly.
Yeah, okay.
Yeah.
So it's tricky.
Yeah, it's a tricky balancing act.
But it seems like there's real momentum building behind this.
Definitely. There's a lot of excitement and
For sure.
a lot of research going on.
It sounds like we're on the cusp of a major shift in how we think about water use.
I think so.
Especially for farming.
Yeah.
So speaking of which, our sources highlighted this fascinating pilot project in Alamogordo that's using a solar-powered desalination system.
That's a cool one.
That sounds pretty awesome.
Yeah.
Can you tell me more about that?
So the project you're referring to involves a farmer, Rolf Loya.
Okay, yeah.
And a company called Harmony Desalting.
Okay.
And they've installed a system on Loya's farm that uses solar energy to power the desalination process.
So it's not just desalination.
Right. It's also using renewable energy.
It's sustainable desalination.
Exactly.
What's really about this Harmony Desalting system?
It's not just about the power source.
Okay.
They're using a process called batch reverse osmosis.
Batch reverse osmosis.
Which means they don't have to run the system continuously at high pressure.
Okay.
So this saves energy.
Okay.
And they're also incorporating nanofiltration.
Nanofiltration?
Yeah.
What's that?
It's another type of membrane filtration process that's somewhere between reverse osmosis and ultrafiltration.
Oh, wow. I didn't even know that was a thing.
Yeah, it's a bit more specialized.
Okay.
And in this case, it's being used to capture more fresh water from the brine stream.
So, again, kind of like getting more bang for your buck.
Yeah, exactly.
Okay.
They're aiming for 90 to 95% freshwater recovery with this approach.
Wow, 90 to 95%.
Yeah, it's pretty impressive.
That's amazing.
Yeah, that means a lot less brine to deal with.
Right, exactly.
Yeah.
It has a real win-win.
Yeah, it's a very promising technology.
Okay. Even with all these innovations, are there concerns that desalination might encourage unsustainable water use?
That's a valid concern, and it's one that researchers are actively debating.
Okay.
Yeah, so some worry that readily available desalinated water could lead to increased groundwater pumping and potentially deplete aquifers faster than they can recharge.
So almost like we're solving one problem.
Yeah.
But creating another one down the line.
Right. It's like, aren't we just kicking the can down the road?
Yeah.
Yeah.
That makes sense.
Yeah.
So it's not just about the technology itself.
No.
It's about how it's implemented.
Right. And managed. It's about finding the right balance between technological innovation and responsible water stewardship.
This has been a fascinating deep dive so far.
Yeah, it's a really interesting topic.
I mean, we've explored the science behind it, the challenges of cost brine disposal, and some of these exciting innovations that are making it more feasible.
More and more feasible.
Yeah, and we've only just scratched the surface.
I know, right?
There's so much more to uncover.
Yeah, there's a lot more to talk about.
But before we dive into all that, let's take a quick break.
Sounds good.
Okay, so we've talked about how desalination could really be a game changer for agriculture. But it's clear it's not a simple fix.
Definitely not.
It's kind of like solving this puzzle with all these interconnected pieces.
Yeah, there's a lot to consider.
Exactly.
Technology, economics, environmental impact, policy, it all ties together.
Yeah, and one of those pieces is understanding the full environmental impact.
Right.
We've touched on brine disposal.
Right.
But there are other factors to think about, too.
Yeah, for sure.
Like the energy consumption.
Yeah, that's a big
of these desalination plants.
Yeah, because it's not exactly a low-energy process, is it?
No, I mean, you're basically forcing water through these tiny membranes.
Right.
That's got to take some serious power.
It does. It requires a significant amount of energy.
Yeah.
But that's where things get interesting.
Yeah.
You remember that solar-powered desalination project we were talking about?
Oh, yeah, the one in Alamogordo.
Exactly.
Yeah.
That's one way to reduce the carbon footprint of desalination.
Right, because if you can use renewable energy sources, like solar or wind, that can make a big difference.
Absolutely.
What about those other environmental impacts, though?
Yeah.
Beyond just...
Well, for seawater desalination, one concern is the potential impact on marine life.
Okay.
If those intake pipes aren't properly designed.
Right, so they're sucking up water from the ocean.
Yeah.
You don't want to be harming...
Right, you don't want to be sucking in and harming marine organisms.
Yeah, okay, so that's something to consider.
Yeah.
And then what about the brine?
Yeah. Even if we find clever ways to deal with the brine from inland desalination, that issue still exists for coastal desalination plants.
So they still have to discharge it somewhere.
Yeah, they have to discharge it back into the ocean.
Yeah.
And it's crucial to ensure that that's done in a way that minimizes the impact on marine ecosystems.
So it sounds like we need a multi-pronged approach.
Absolutely.
Both on the technology side and in terms of regulation and monitoring.
Environmental regulations, monitoring. Yeah. It's really about finding that balance between harnessing the potential and safeguarding our environment.
So we've talked about the technology, we've talked about the environment. What about the economics of all of this?
Yeah, that's the other big piece of the puzzle.
I mean, even with things like solar power and more efficient membranes, is desalination still just too expensive?
Well, cost is definitely a major factor, but you have to remember the cost of inaction.
Oh, okay.
What's the economic impact of water scarcity on agriculture?
Right.
Lost crops, reduced yields, higher food prices.
That's a good point.
These are all real costs that we have to factor in.
So it's almost like we're weighing the cost of desalination now against the potential cost of doing nothing.
Exactly. It's a long-term view.
Yeah.
And the cost of inaction can be quite significant.
So how do those costs actually compare?
Well, there have been studies looking at this, and the numbers vary depending on a lot of factors.
Right.
The type of desalination technology, the source of the water, the energy costs, and so on.
Okay.
But what we're seeing is, as desalination technology improves and the cost of traditional water sources rises, that gap is narrowing.
So it's becoming more competitive?
Yeah, I mean, it's still more expensive.
Right.
But it's getting closer.
Okay, so even if the cost becomes more manageable, is it really a sustainable solution in the long run?
That's the million-dollar question, isn't it?
Yeah, I mean, are we just kind of delaying the inevitable?
Right.
By making it easier to access water?
Are we just kicking the can down the road again?
Yeah, I mean, shouldn't we be focusing on reducing our consumption?
Well, that's a crucial question. And it gets to the heart of what we mean by sustainable water management.
Okay.
Desalination can be a valuable tool, but it's not a silver bullet.
Right. It's not a get-out-of-jail-free card.
Exactly.
Okay.
So we still need to be smart about how we use water, regardless of where it comes from.
Okay, so it's not a replacement for conservation efforts?
It's a complementary strategy.
Right. So you still need to do all the other stuff.
You got to do all the other things. This is one piece of the puzzle.
An additional tool in the toolbox.
Exactly. And just like any tool, it needs to be used wisely and strategically.
So if we bring it back to Ralph Loya, our farmer. What does all this mean for him?
Well, for farmers like Ralph, desalination could potentially be a lifeline. It could mean the difference between being able to continue farming and having to abandon their land due to lack of water.
So the stakes are pretty high.
The stakes are very high.
Okay.
Yeah. I mean, this is their livelihood we're talking about.
But it's not just about individual farmers either.
No, it's much bigger than that.
It's about
the whole... It's about the entire agricultural industry and food security.
Food security,
As water scarcity becomes more widespread, desalination could play a key role. in ensuring that we can produce enough food
to feed everyone.
To feed a growing population.
Right. So there's a lot riding on this.
There's a lot riding on it.
But we need to make sure that it's done responsibly.
Absolutely.
Environmentally, economically.
It's about finding that balance.
Okay.
We need to learn from these pilot projects, the research, the ongoing debates, to make sure it's implemented in a way that benefits everyone.
People and the planet.
People and the planet, exactly.
That's what I said. Now, before we wrap up this deep dive, there's one more aspect we need to explore.
Okay.
And that's the policy side of things.
Right, because even with all the technology and the economics, desalination isn't going to take off without the right policies in place.
So what kind of policies are we talking about here?
Well, for starters, we need clear regulations regarding brine disposal and environmental monitoring. You know, we can't just be pumping salty water back into the environment.
Right, we talked about that.
We don't want to create new problems.
Yeah, for sure.
We also need policies that promote water conservation and incentivize the use of recycled water.
Right, so desalination shouldn't be seen as a replacement.
Exactly.
For those efforts.
It should be part of a broader strategy.
Okay.
And then there's the issue of water rights and allocation.
Ooh, yeah, that's a big one.
Who gets access to the desalinated water?
Right.
And at what cost?
Yeah, those are tough questions.
These are complex questions.
It sounds like there's a lot of work to be done.
Yeah, the policy landscape is crucial.
On the policy front,
we need policies that encourage innovation, provide incentives for farmers to adopt water-efficient technologies, and ensure equitable access to water resources.
So it's another layer of this whole puzzle that we're trying to solve.
It's a multidimensional puzzle for sure.
This deep dive has been a real eye-opener.
Yeah, it's a fascinating topic.
We've covered so much.
We've gone from the science.
Right, from the science.
To the economics.
To the environment, to the policies.
It's all connected.
Yeah.
Yeah, it's really interesting to see how it all ties together.
It is, and I hope our listeners are feeling as informed as I am.
Hopefully, yeah. I think it's important for people to understand these issues.
For sure.
Because they affect all of us.
Yeah, absolutely.
So hopefully this deep dive has shed on light on.
Right. And before we wrap up, I'd love to hear your final thoughts.
Okay.
What's like the one key takeaway you want our listeners to remember? I think for me, it's that reminder that innovation isn't just about cool gadgets and futuristic tech.
Right.
It's about solving real-world problems.
Exactly.
And in this case, it's about using science to address a really fundamental human need.
Yeah, I mean,
access to clean water.
Water is essential for life. So, it's inspiring to see how researchers are kind of pushing the boundaries of what's possible with desalination.
And it's not just happening in labs either.
No, exactly.
It's being implemented in the real world.
Yeah.
Out of the field, like on Ralph Lauder's farm.
Yeah, I mean, that's what's so exciting about this. It's not just theoretical.
It's actually making a difference.
And it's not just about the technology alone.
No.
It's about how it's being combined with other strategies.
Yeah, like water conservation.
Right.
Efficient irrigation.
Soil amendments.
Yeah, they're even using things like compost to improve the soil.
So it's like a whole system.
It's a holistic approach. It's not just about one thing.
Right, and that's where policy comes in too.
Yes, absolutely.
Because even with all the technology and sustainable practices, you need the right policies to support it.
Right, to make sure that it's done responsibly.
And sustainably.
Right. This deep dive has really given me a lot to think about.
Yeah, me too.
I mean, it's clear that desalination has the potential.
Yeah, huge potential.
To be a major part of the solution. But it's not a simple fix.
No, it's complex.
It's a complex issue.
There's a lot of factors to consider.
Yeah, and it requires this multifaceted approach.
Right, you have to think about the science, the economics.
The environmental impacts.
Social implications.
It requires these thoughtful conversations.
Yeah, I mean, we need to be talking about this. We need to be weighing different perspectives and making informed decisions.
So as we wrap up this episode, I want to leave you, the listener, with a challenge.
Okay, a challenge.
We've explored this potential of desalination. We've talked about the complexities, the questions that remain. And now we want to hear from you.
Yeah, what do you think?
What are your thoughts?
What are your questions?
On the role of desalination in creating a more water-secure future.
You know, maybe you're wondering about the potential impact of desalination in your own community.
Right. Or maybe you're curious about the latest research on energy-efficient technologies.
Yeah, there's so much happening
there is.
In this field right now.
And it's a conversation that needs to involve all of us.
Exactly.
Because the future of water is the future of all of us.
It really is.
So let's keep this conversation going.
Thanks for joining us.
And thanks for listening.